Hello geometry, welcome to another week. This week we're talking about reflections. Now, reflections, like in a mirror, absolutely has the same meaning as in mathematics. Now, before we can talk about reflection specifically, we have some vocabulary to go over as well. The first vocabulary word is transformation. Please channel your inner Optimus Prime when thinking about this because it has the same meaning. Optimus Prime transforms, meaning he becomes a different thing. He changes what he looks like. In mathematics, the transformation refers to more about movement than necessarily becoming a car. But the idea of a transformation is to change or move. And in this particular context, we're talking about on the coordinate plane. And so as you can predict, what a reflection does is it moves the shape or point on the coordinate plane from one place to another. So a reflection is a type of transformation. Now, to talk more about that a little bit, we're going to be having two more words so we can be specific about what the original shape is and what the reflected shape is. And those two words are pre-image and image. The pre-image is the original shape. Pre as in before. The pre-image is before the transformation. That would mean that the image is the shape after the transformation. It is the transformed shape. So, 3 words so far. Transformation is a change or movement on the coordinate plane. The pre-image is the original shape, and then the image is after it's been moved or after it's been transformed. And so, when we talk about the movement of shapes and the changing of shapes, there's 2 ways we really talk about it. One of them is about changing its size, and the other one is talking about just changing its location or orientation. And so, the way we differ between those is we use the phrase rigid motion. So when you think of the word rigid, oftentimes people think of the word rough. When you feel something rigid, it feels rough on your hands. It's hard. It's not squishy or soft at all. And the reason why we think of the word rough is because what rigid means is it's unmoving. It's structure. It's not flexible. And so when we feel something rough, it's because the grains or the ridges or whatever it is that we're feeling is not flexible. And so here when we talk about a rigid motion, it means it's a transformation that doesn't actually change the shape itself, just its location or what direction it's facing. But the shape itself, if it starts as a triangle, it'll end as a triangle that's the same size. Nothing about it changes except where it is and what direction it's facing. And so when we want to describe that academically, we're using the word preserves, like jam. If it preserves something, it stays the same. A preservative keeps food the same. And so a rigid motion preserves angles and distance. Let me go a little bit more into that. So when I say a rigid motion preserves angles and distance, really what I'm trying to describe is what the shape looks like and how big it is. If we go back to the example about the triangle here. Don't you like my triangle? I think it looks pretty cool, except I want my triangle to be a little bit bigger for this example. If I want to talk about this specific triangle, and I tell you that these angles are 50, 70, and 60. If this is a rigid motion, then that triangle with the 50, 60, and 70 degree measures will still have those three measures after the transformation. So if I decide to turn this into a different orientation, so rather than the 60 on top, I put the 50 on top now. Well, this is the same triangle with the 50 on top instead of the 60 on top. I've just made it so that a different angle is on top, but all three angles are still the same. The motion, the change was rigid. It's the same shape, just in a new location with a new direction. And the reason why I can tell is because all the angles are still the same. The other way we can tell is when I talked about that distance piece. All three sides will still need to be the same size. It can't be any bigger or any smaller of a shape. And so a rigid motion preserves the angles of the shape and the distance of the sides. And so the extra super fancy word to describe this, if you want to talk about a rigid motion to the real academic elites of the world, then you're using the word isometry. That means a rigid motion. So, a rigid motion preserves the angles of a shape and the distance of its sides. The only last piece to talk about here is a word that we talked about in the previous unit. It is the word corresponding. So the word corresponding in our previous unit referred to angles on parallel lines. We talked about corresponding angles. But the reason why that made sense was because corresponding, like in the last unit and like right now, just means to match. And so if I look back to the example that I drew already, the 50 degrees, I'll go ahead and highlight that in a nice color here. Purple's a great color. So angle A here is our 50 degrees. That is going to match the angle after the transformation that's also 50 degrees. Those are the matching angles in the pre-image and in our image. The pre-image has A to help identify that a transformation has happened and that I am talking about matching points. I want to have a name that clearly communicates that. And so, ladies and gentlemen, that's where we talk about using the same letter but differentiating it with a prime. And so a prime is the little tick mark that goes in the top right-hand corner, and depending on the number of transformations, we just add more tick marks. And so if 2 transformations or 3 transformations happen, then I'd have a double prime or a triple prime. And we could just keep adding tick marks up there to help count how many transformations have happened. And because it's still the letter A all the way through, we're able to keep a track of what our matching angles are, what our matching points are, right? And so, ladies and gentlemen, because this is a name, we technically don't have to use the letter A. We could have used any letter. Could have been J, could have been R, could have been Q, and we would not use a prime if we used a different letter, but it would be really, really hard to know what our matching angles are, right? We want to clearly communicate to other people what the matching angles are, so we choose to use the same letter on purpose so other people can tell what our matching angle is. And so here, in this example, I've only done one transformation, so A goes to A prime. And that's going to be true for the other angles as well. So if I wanted to spell cat, our 60 degrees would be C. It would match up to the 60 degrees in our transformed shape. So that would be C prime. And then our 70 degrees is going to be T. And so the new 70 degrees is going to be T prime. So C corresponds with C prime, A corresponds with A prime, and T corresponds with T prime. So, ladies and gentlemen, those are the key vocabulary words so far. It's going to be a nice little document here that I'm going to be able to load up, so you'll be able to come back and watch and read it and have that as a reference. Ladies and gentlemen, I look forward to seeing you in the next video. Take care.